Okay, so now guys, we're going to solve a compound inequality again. In this case though, it's not an or inequality, it's an and inequality. So remember, in an or inequality, it only has to satisfy one of the two solutions. In an and inequality such as this one, it's got to satisfy both. Now notice this one looks a little weird. And if you remember from lesson one, we had an x that we were able to put in the center, and then we had our two symbols, and then we had our two numbers. So this, when you see this written, it indicates to you that this is an and compound inequality, which means whatever x value we put in for this one, it's got to satisfy both. Now, here's what else is weird. When you look at this inequality, you don't truly see two different ones. So notice in the or one, we had one over here and we had one over there. We had the word or in between them. Here we don't have that. Here we got all things together. However, there actually are two inequalities written here. So when you solve this, you have to solve this by doing two different inequalities. Here is your first inequality. Your first inequality comes from here. So when we solve this first one, we can kind of ignore the less than 16 over here. And all we're going to solve is negative 12 less than or equal to 7x plus 9. Okay, and remember, this is an inequality, so you could also think, if you think backwards, this could say 7x plus 9 is greater than or equal to negative 12. Doesn't matter how you read it, as long as you read it left to right, right to left. As long as you read this sign correctly when you read it that way. Simplified on both sides, as always. I'm going to keep saying that because I want your brain to go through high school and say, well, Mr. Zernick said simplify both sides. If they're both sides, now I can start with properties of equality. So that's what we're going to do. Take 9 away from both sides. When I take 9 away from both sides, the only thing left over there is still 7x. Take 9 away over here. I have 12 negatives, 9 negatives. That gives me 21 total negatives. So negative 21. In order to completely simplify this and use the other property of equality, the other property of equality we have to use is division, because that's multiplication. So divide both sides by 7. X is greater than or equal to negative 3. Now notice I did read it backwards here because I want you to read the variable first so it makes more sense to you whenever you try to graph this. X is greater than or equal to negative 3. And now, where's the other inequality? The other inequality is located right here. Okay, that is 7x plus 9. Notice that that is true for both. It is in both of the inequalities. Is less than 16. Now I'm going to switch back to the black marker just because I think you guys can see it better on there. So here we do the same thing again. This is simplified, that side simplified. Let's use our properties of equality. We're going to use the subtraction property of equality because, again, it's plus 9, so we're going to take 9 away from both sides. Notice we took 9 away from both sides over here. We're taking 9 away from both sides over here. So if you can remember that about an inequality, you're doing the same thing to both of these things. So if I take 9 away, once again, all I get is 7x. And if I take 9 away from that side, now it's positive 16 minus 9, which is equal to 7. Once again, use the next property of equality. That's multiplication. Undo it with division. So divide on both sides. X is less than 1. Okay, so we read x is less than 1. We read x is greater than or equal to negative 3. So this x, guys, lands in between those two. So if I have negative 3 here, 0 here, 1 here. X is less than 1, going in this direction. X is greater than or equal to 3, heading in this direction. And notice they'll both come together. So in order for there to be an answer to this and inequality, it can only be the numbers that are between these two, because they are the only ones that satisfy both. Unlike our or one that we just did for our other example, our or question only had to satisfy one. This one has to satisfy both. So our answers will all simply be here. Negative 3 is an answer because it's shaded in. It's part of the answer. 1 is not part of the answer. It is just a boundary. So everything up to 1 will work, but 1 will not work. Notice if you put 1 in here, 1 is not less than 1. That's why it does not work. Okay, so I hope you saw the difference in the and the or inequalities. And I hope you're able to, I hope this is becoming a little bit quicker for you because, again, we're using the same simplifying processes and equality properties in order to answer all of these things. I think you should be able to get through most of the practice and the additional practice with this. Don't panic if you can't. Obviously, we're going to be in school next week a little bit, so I'll help you out. If you're stuck on something and you really want to get finished with it or you really have big questions, please email me. Don't panic. I know some people will get questions and they don't understand them right away. Um, Sometimes they're hard for me to get to, but we get them. We'll work until we get to the answer. We did that actually today while we were in algebra class. Okay, good job. Keep it up. Talk to you next week.